Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. For more detail, you can visit our website www.sapienseducation.com. You can also download our app for each and every courses. Description of the apps given in a description section. Okay, okay. Link is being provided. So today I am going to teach you or solve some solution, and I will show you the shortcut techniques how to solve the NCERT question. Okay. So first of all, take 4.16 and 4.1 to 4.15. I have already done a video, so you can also visit there. So for this section, I am going to teach you now. Now 4.6, what they are telling, what they are telling. Try to understand what they are telling. Read the question. If you want to read the question, you can read. Two mass of 8 kgs and 12 kgs are connected at the two ends of a light inextensible string that goes over frictionless pulley. Find the acceleration of the mass and the tension in the string when the mass are released. So let us consider there is a pulley. Okay, there is a pulley and there is a mass. So let us consider there is a two mass is being hanged by the help of a string. So let this mass be like this. Okay, so two mass are there. Okay, so these are the two mass. Now this mass is of 8 kg and this mass is of 12 kg. Okay, now they want acceleration as well as tension. So tension will act upward. Here also tension will act upward, and downward force there will be mg, that is equal to 12 into 10, and here also there will be mg force, that is equal to 8 into 10. Okay, since acceleration is in upward direction, since acceleration is in upward direction for this object, so acceleration will be this, and in this acceleration will be like this. So I will use free body diagram. So free body diagram for the mass 8 kg. So let us consider free body diagram for a mass 8 kg. So this is your 8 into 10, that is equal to 18 Newton is acting downward. Tension is acting downward. Since acceleration is upward, so there will be a mass into acceleration, that is 8 into acceleration will be downward. So from here we can write here tension T minus 80 Newton minus 8A is equal to 0, or tension T is equal to 80 plus 8A. Now again you use the free body diagram of this body of a mass 12 kg. Free body diagram of a mass is equal to 12 kg. So if I will take the free body diagram of a mass having a 12 kg, so what we have to write here? So 12 into 10, that is equal to 120. Newton is acting downward direction. Tension will act at upward direction. Since acceleration is downward, so we need to add pseudo force like this. So this is equal to mass, that is equal to 12 into acceleration. So all three forces we can equate here. Tension plus 12A minus 120 is equal to 0. So tension can be written as 120 minus 12A. So you have got equation 1 and equation 2. Since strings are same, since here strings are same, right? Strings are same. Since here strings are same, means what? Tension will be equal. Try to understand. Here T is equal to 80 plus 8A, and here T is equal to 120 minus 12A. So can we equate here? Can we equate here? So we will equate here. So this is equal to so 80 plus 8A is equal to 120 minus 12a. So this will be 20a is equal to 120 minus 80. So this is equal to 20a is equal to 40. A is equal to 40 divided by 20. So this will be 2 meter per second square. So you have got acceleration, right? Now the next, in same question they are asking tension. So tension will be put anywhere, you will get the answer. So 80 plus 8 into a, that is 2. So this is 80 plus 10, 2 8 is 16. So this will be 96 Newton. So we have got tension 96 Newton. I hope you have understood now. Now I will discuss next question. I will discuss next question. Now this question, what they are telling, nucleus is at rest in a laboratory frame of reference. Okay, so let us laboratory from reference has a nucleus. This is a nucleus. Okay, shows that if it disintegrates into two smaller nuclei, the product must move, so that if it disintegrates into two smaller nuclei, then the product must move in opposite direction. So as per it, if product will be there, so one product will be move in this direction and another product will move in this direction. So let us consider there is a total mass is m and initial velocity is 0, because nucleus is at rest. Nucleus is at rest. So initial momentum will be, total initial momentum will be mu, that is equal to 0. Now I will talk about final momentum, because since it has been integrated into two parts. So let us consider this as a m1 and v1, and it has mass m2 and velocity v2. So total momentum, m1 v1 plus m2 v2 is the final momentum. Now as per conservation of momentum, as per conservation of momentum, conservation of linear momentum, initial momentum will be equal to final momentum, that is 0 is equal to m1 v1 plus m2 v2. Now if I will move this equation like this, so can we write here m2 v2 is equal to minus m1 v1. So can we write from here that v2 is equal to minus m1 by m2 into v1. Since this m1 by m2 is always positive, because mass cannot be negative, so finally we get that v2 is equal to minus of v1. So velocities are equal but opposite in direction. Velocities are constant term into velocities are in opposite direction. So not, I cannot tell both have a same velocity, but they are definitely, I can tell that both have opposite direction. So this is what the questions are trying to ask you. Okay, so I hope you have understood now. Now let us solve another question, that is 4.2. okay, 4.18. okay, now what the question are asking, two billiards ball, each of a mass is 0.05 kg, moving in opposite direction with the speed of 6 meter per second, collide and rebound with the same speed. What is the impulse imparted to each of the ball? So let us, there is a ball, okay, and it is moving with the initial velocity u of 6 meter per second, okay, and it has a mass of 0.05. Another ball which is moving in this direction, so it's a u1 and it is u2, and u2 is also equal to 6 meter per second, but it will be negative because it is going in a negative of x-axis and it is positive. Now as they collide, see they have a same mass 0.5 kg, okay, 0.5 kg. As they collide, what will happen? As they will collide, then what will happen? They will move in different direction. That is equal to velocity v1. v1 will be equal to minus 6 meter per second, and velocity v2 will be equal to plus 6 meter per second. Now we want impulse imparted. So impulse is equal to what? Impulse is equal to force into delta t. Force is dv by dt, delta t into delta t. Force is known as change in momentum by delta t. So delta t can be cancelled out. So impulse can be written as change in momentum. Change in momentum. Okay. So impulse imparted to each ball. So let us take ball 1. Let us take one ball 1. Let us take ball 1. So if I will take ball 1, so this, suppose this is a ball 1 and this is a ball 2. Okay. So initial momentum of ball 1 is equal to mass, that is equal to 0.05 into 6, that is equal to 30, 0.3 kg meter per second. And what is the final momentum? So this will be equal to minus 0.05 into minus 6. So this will be minus, this will be what? Minus 0.3 kg meter per second. Okay. Now since here you can see that initial momentum of this body 1 is 0.30 kg meter per second, and final momentum of this body is minus 0.30. Okay. And for body 2 also you can see here initial momentum will be equal to minus 3.0 and final momentum is plus. So impulse imparted in each body. So if we talk about impulse imparted in body 1, so impulse imparted in body 1, that is equal to engine momentum, that is P1F minus P1I, and this is equal to minus 0.3 minus 0.3. So this will be minus 0.6 kg meter per second. And for this ball also, for ball 2 we can also say that momentum, that is equal to change in momentum is equal to P2F minus P2I. So this will be equal to 0.30 minus 0.30. So finally you will get 0.6 kg meter per second. So impulse imparted is this. I hope you have understood. So what is the impulse imparted to each ball? So you will get each ball has same but the in opposite direction. So both have same impulse imparted, but one has in opposite direction and another is in other direction. Now I will solve a question number 4.1a. A cell of a mass is how much? Mass of the cell. You know that there is a gun and there is a cell. Okay. So it is at a rest condition. So after rest condition, so what happened? Second, it is a second condition. It is a second condition where a bullet has some speed. Okay. So see here, a cell of a mass 0.2020 kg is fired by a gun of a mass 100 kg. So if the muzzle speed of the cell is 80 meter per second, what is the recoil speed of the gun? So its speed is how much? 80 meter per second. And its speed of a velocity of gun, we want velocity of gun, so we don't know. So it initially momentum is 0, initially at rest, so initial momentum p initial will be equal to 0. What will be the p final momentum? So final momentum, as we know that equal and opposite force, so what will happen? See here, velocity of gun will be in negative direction if I will consider the velocity of the cell in positive direction. What is the mass of the cell? So mass of the cell is 0.02. And what is the mass of a gun? Gun has a mass of the gun is equal to 100 kg. So can we write here? And momentum, total momentum, of the system, gun and cell system. So I can write here mass of the gun into velocity of the gun plus mass of the cell into velocity of the shell. So mass of the gun is 100 into velocity of the gun is Vg, and plus mass of the cell is 80 into velocity of the cell is mass of the cell is velocity of the cell is 80 and mass of the cell is 0.02. So this is final. So as per conservation of momentum, what we can write? Initial momentum will be equal to final momentum, but here final momentum, initial momentum is 0, so final momentum should also be 0. That means that we can write here 0 is equal to Vg into 100 and plus 80 into 0.02, so this will be 0.16. So from here we can get Vg is equal to minus 0.16 divided by 100. So this is the velocity of gun, right? So here we can take like this 100. So 18 into 2, 160. 160 divided by 100. So this will be 1.6. Sorry, it will be 1.6. So this will be 1.6 by 100. So if it will be 1.6 by 100. So it will be minus 0.016 meter per second. So why it is minus? So minus is, it means that the gun will recoil in this direction. Okay, I hope you all have understood now. Now I will solve next question, that is batsman. A batsman deflects a ball by an angle 45 degree without changing its initial speed, which is equal to 54 kilometer per hour. And what is the impulse imparted to the ball? So same impulse imparted. So let us this is a bat. So a ball is coming and gets deflects by an angle of 45 degree. So as per the question, they are saying that initial velocity is your 50, initial velocity u is your 54 kilometer per hour. So why don't we change it to meter per second? So it will be 5 by 18 meter per second. So this will be 15 meter per second. Okay, so initially it was 15 meter velocity b. Okay, let us consider this is the angle. What this angle is? So if I will go for symmetry, so this will be 22.5 degree. Okay, so this will be 22.5 degree. This is also 22.5 degree. Okay, so can we take its component? So its velocity's component will be this velocity. Suppose initial velocity is v1. It has two components. See here, in downward direction, that is equal to this is also v in downward direction, that is equal to v cos 22.5 degree, and component, this is also with the same speed, so its component will be in downward direction, that is equal to v cos 22.5 degree. Okay, so you are getting two component, two in this direction, downward direction, no change in a direction, no change in direction, and so initial momentum and final momentum will be zero, because both are in a same direction, both are in same direction. Okay, no change in a direction, right? No change in a directions are happening, so no impulse is imparted, no impulse is imparted, impulse is imparted. Okay, no impulse is imparted. But in this direction, in horizontal direction, if you will tell, so we are getting, due to this force, we are getting v cos 22.5 degree, and in this direction v, due to this force, we are getting v cos 25 degree. So impulse imparted will be, impulse imparted will be equal to initial moment, final momentum minus initial momentum. So final momentum is how much? Final momentum is your mass into v cos 22.5 degree minus initial momentum is same. My initial momentum is how much? Minus of minus sorry, final momentum is minus mv cos 25, and initial momentum is your minus m v cos 22.5 degree. So by using this, we are getting m into velocity into cos 22.5 degree. So when you solve this, so what you will get? It 2, what you will get? 2 into, what is the mass of the ball? Mass is how much? Mass of the ball is 0.15. So you can find here 0.15 into cos 22.5 degree. So how much it will be? How much it will be? So try to calculate it. Cos 22.5 will be equal to 0.92 into 0.15 into 2. So this you will get, finally you will get minus, finally you will get minus 277. So this is the impulse imparted, minus 0.277 kg meter per second. This is the impulse imparted. Okay, thank you. I hope you have understood all this. Thank you everyone. We will meet any type of confusion you may ask directly. Thank you everyone.